My name is Madeline Acri. I am the Energy Storage Manager at Soligent, and we have Kelsey here, our marketing manager. She will be assisting as well. So if you have questions, you can enter them in the Q&A or in the chat, and we will be managing that so that we can talk about the storage topic today and answer any other questions. So without further ado, I'm going to just dive right in. So last month, we talked about kilowatt hours and kilowatts as it referred to storage. And I want to spend a little more time talking about the PV sizing, because we talked a little bit about PV sizing and how the array should be designed based on if you have storage versus if you don't. And we talked a little bit about the AC-DC ratio last time as well. So we're going to just kind of continue on that topic and talk about how you should select your PV based on how much storage you have. So what's that going to look like? We'll talk a little bit about who I am, and then we'll dive right into making sure you understand how much energy you need to be providing storage for. Because depending on how your battery is going to be operating, depending on the programming of it, you may have larger or smaller energy requirements. So we can talk about that. Then the battery is sized in kilowatt hours, and then the PV is going to be sized in kilowatts, but that's going to be paired with the kilowatt hours of your battery bank. And then the kilowatt sizing is going to be based on the maximum inverter size. So making sure that you can distinguish between kilowatt hours as it refers to energy and kilowatts, and then where PV sizing fits into all of this. That's what we're going to review today. So not too much to discuss, just a good topic. So I'm Madeline. I've been with Soligent for about 2.5 years now. And I've been in the solar plus storage space since 2016. My role here at Soligent is to help customers, be it an installer or a homeowner, understand how energy storage works and how energy storage is complementary to a solar system. And at this day and age, we have a lot of different brand options. So a lot of people have kind of heard of, oh, I think I want batteries. I probably want a Powerwall. Well, a Powerwall does provide storage, but there are a number of other brands that also provide storage. So I help make sure that people are getting the right equipment for what their project is needing and what's most suitable. So I am always in touch with different vendor partners to make sure that we have the latest and greatest technology for all of you. So let's start by looking at an electricity bill. And this is a snippet actually of my Austin Energy kilowatt hour usage. So Austin Energy provides me a running tally of the kilowatt hours that I use every month. So this, the electricity began on my account in April of 2021, and then this snippet was from February of 2022. So this most recent bill was for 267 kilowatt hours. As you can see, for the last column, we're at 267 kilowatt hours. So for that month of February, we had 28 days of energy usage, which makes sense. And since I used 267 kilowatt hours for the duration of that service period, the average kilowatt hours per day was 9.5. Okay. 9.5 kilowatt hours on average per day is relatively conservative. That's a small amount. And we can see that November, December, January, and February of the end of 2021 going into 2022, it's on the lower side. 250 kilowatt hours or less, more or less, is pretty modest. But if we look at the summer, which is when my central air conditioner is running, this is almost orders of magnitude more. September was the most electricity intensive month that I experienced in 2021, and that was basically 1,300 kilowatt hours for the month of September. So if we look at the average usage of kilowatt hours in September, we're looking at 43 kilowatt hours compared to February, which was 9.5 kilowatt hours. We're just going to be talking about the energy needs right now. So that's what we're comparing. Do I want to size my energy needs for my battery based on a 43 kilowatt hour day or a 9.5 kilowatt hour day? And these values are for my entire home. But of course, my whole house is going to be much larger than if I were to separate an aggregate subpanel. So if I want batteries for emergency backup on a subpanel, my subpanel is not going to include my central air conditioner. I know that right now. I do not want to pay for the batteries necessary to provide 43 kilowatt hours for a day. So you can kind of take your whole house usage over the course of a year as a benchmark, but that's going to be not the exact same as the energy needs of your subpanel. So when we actually size our battery, we want it to be based on a subpanel. And again, this is assuming we're going to be making a subpanel for emergency use only. If we want a battery, we'll talk about why we might want a battery beyond a subpanel coming right up. So the two questions that I want to ask are, when will the battery run and what will the battery power? Those are the most fundamental questions anytime someone is sizing a battery bank. So more and more common, people are seeing time of use, or they're wanting their battery to provide electricity savings during times when your electricity may be more or less expensive. So if I know that my electricity is going to change the rate, or it's going to be much more expensive on an energy level, so a kilowatt hour level during a set amount of time, I want to understand that that's what I'm sizing my battery for. If my primary use for this battery is time of use settings between 4 and 9 p.m., that's what I want my battery to run for. If I also want to use a battery during an emergency circumstance, but I haven't sized it for that, the expectations on the performance of the battery are going to be different if you're using it for something that you didn't intend it for. You can design a system to say, I want it to be time of use for 90% of the time, but if there is an emergency, I also want that to work, and I also want the loads in my home during an emergency to be functional. You want to have while you're designing the system. So self-consumption is another option for people who have bad net metering rates. So if you're producing excess PV during the day and you are not using it immediately, but you do not want to sell it back to the grid because you may not be compensated, you can store it and then you can use it. So if we assume, just for an example, that let's say the sun sets at 6 p.m. and the sun rises at 6 a.m., I want my battery to be able to store the PV that is being generated throughout the day that I may not be using, so that I can use it from my battery between 6 p.m. and 6 a.m. These are more finite times that you can kind of wrap your head around, because you know when the sun is going to rise and set every day, give or take cloud coverage or storms or what have you. But you know you want your battery to be able to get you through the night, ideally on the power that you generated yourself. And then I would say the most common use case we're still seeing for batteries is for emergency backup. And this may be supplemented with a generator as well. But the grid could go down really at any time under any circumstance. If someone is working on a utility line, or if a tree falls and causes a disruption in your service, it's hard to anticipate when that will happen. It's also hard to anticipate how long that's going to cause an outage. So you want to just design a system based on what circumstances you think you're going to be experiencing an emergency under. And often this may be, let's say, a couple days, maybe 48 hours is the maximum amount of battery you're going to design for. Otherwise, you may need a supplemental service if you have an outage for 5 days. I might also want a generator, something like that. We just talked about when the battery is going to run. Now we want to know what the battery is going to power. So during time of use, if electricity is very expensive between 4 and 9 p.m., between 4 and 9 p.m. on any given day, I may be using a lot of appliances. I may be running my electric cooking grill or my oven. I might be running the dishwasher or the clothes washer or the clothes dryer. So I still want my battery to be able to power anything I expect to be using during a given day. This is not really a conservative time. I want to save money by not using the utility power during this time, but I'm still going to be living my life normally, potentially, assuming the homeowner doesn't want to shift their lifestyle. But between 4 and 9 p.m., I can say I want my battery and my storage system to be able to provide energy and power for everything in my home at that time. Fine. That's something you want to determine. Self-consumption, similarly. If you really are more concerned with getting through the night or just making sure that you're using all of the PV that you're generating during the day, this may be spread out for a longer duration. So during the nighttime, I may not be running my large appliances. I might really just need to kind of keep my house on standby mode, if you will, during the night. But again, we want to just determine what do we expect is going to be running off of my battery at any given time. Emergency backup is going to be a little bit different. Maybe you want to shift to only the essentials. So I took away some of the appliances that we might consider optional. So I still want my toaster, maybe electric kettle, microwave, and fridge to run. Those are what I would consider essential. Maybe I still want an electric heater of some kind. I don't want to freeze. Understandable. So select your essential loads and put them on a subpanel. That's going to be how you determine what your battery is going to run during that time. If you want everything in your house to be used during an emergency situation, that's fine. You can design a whole house battery for emergency backup as well. It's just important to make these considerations, before an outage occurs so that you have set expectations on, the power is out, or, the electricity rate just shifted to, 30 cents a kilowatt hour. What's my battery going to be doing? And how am I going to be using my home in accordance to what I expect my battery to do? Okay, this is sort of the slide we've been waiting for. How do we decide how much PV we want based on our battery usage? So if we size based on the battery, it's going to be different than if we size just based on, the sun is shining, I have net metering, I can just export anything I want to the grid. So in this example, let's just say I want my battery's use case to be emergency backup, and I only want essential loads to be running. Let's say I want my essential loads to run for 2 or 3 days. Maybe I can get away with 15 kilowatt hours for total needs. I know that 15 kilowatt hours is how I want, and that will get me through 2.5, potentially 3 days. Okay. Now we want to consider the sun, because if we're using a solar and battery only situation, let's just assume we don't have a generator. I need to size the PV based on when the sun is shining. And it may be based on my worst case scenario. So in the wintertime, I may only have 4 sun hours versus the summertime, I may have 6 or 7 sun hours. I want to say, what is my sun hour duration? And then how big is my array going to be able to absorb all of that sun while it's shining? So I have 2 little examples here. Let's just pretend like I have a smaller array is going to take longer to fill up my battery the same amount. So it may take 5 hours for a 3 kilowatt array to absorb all of the sun to achieve my 15 kilowatt hour battery bank need, as opposed to I only need 3 hours of quality sunlight on a 5 kilowatt array to achieve that same thing. So from a dollar perspective, you may be better off selecting a 5 kilowatt array that you only need to be sunny for 3 hours, so that I can use some of that power while the sun is shining. And if I'm in a storm circumstance, know that I'm going to be okay if I have only 3 hours of sun versus needing to rely on 5 full hours on a 3 kilowatt array to achieve this 15 kilowatt hour amount that I need. So that's kind of the rule of thumb, is how much sun is going to be shining during my given time, and what is my array size in order to absorb all of that. And this 15 kilowatt hours would be, let's just assume we're not using anything during the day. We're just absorbing the sun. If you say, I know I'm going to actually be using the solar and charge my battery simultaneously, I might want a slightly larger kilowatt size on my panels so that I can know I have enough solar to store up my battery and use it at the same time. Okay, let's shift gears from setting our solar size to, if we know our 15 kilowatt hours, how big should my battery bank be? And this answer is different depending on what battery you select. So most lithium ion technologies, whether that's lithium ferrophosphate or nickel manganese cobalt, both of those are different lithium chemistries. Their depth of discharge is nearly 100% or 100%, depending on how you set your system. Similar to how you would use your cell phone battery. So if I am only using my battery for emergencies and that won't be cycled all the time, maybe I want to set it to 100% depth of discharge. If I have a 15 kilowatt hour need and I can use 100% of the depth of discharge of the battery, that means that I only need a 15 kilowatt hour battery bank. However, if I want the battery to last a little bit longer and I want to set the depth of discharge slightly less, so I'm only depleting the battery 80%, up to 80% in a given instance, then I'm going to need to size my battery bank larger to make up for that kilowatt hour buffer. So 15 kilowatt hours at my house on an 80% depth of discharge battery is going to be a 19 kilowatt hour battery bank. Again, this is based on an 80% depth of discharge lithium battery. If we shift gears to lead acid, which, I know it's 2022, but I still want to give a shout out to lead acid, because if someone just wants a backup for something that is not going to happen very often and they just need to get them through a little bit of time, lead acid is still relevant. It's much cheaper. So I still want to mention it. However, I may be designing this only to 50% at the discharge. So my entire battery bank capacity is going to be 30 kilowatt hours, but I always want 50% of this bank to be left. So I'm only cycling it a little bit, up to 50% on a given instance. And then if I hit a low voltage reading, if my battery has gone down to 50%, it's going to shut off. It's either going to trigger a generator to turn on, or my system is going to power down, because I know I don't want to deplete the battery beyond 50% in order to maintain the longevity. So just take the depth of discharge of your battery into consideration when you're designing your battery bank, because your energy needs may not be the same size as your battery bank. A 100% depth of discharge is really the only time when your energy needs are going to match the exact size of the battery bank. In any other instance, if your depth of discharge is 80% or 50%, you're going to need a larger battery bank to consider that. So now let's talk about the inverter size, because a lot of times people talk about batteries in terms of kilowatts, and that is not correct. a battery has a capacity in kilowatt hours. It also has a kilowatt output, but the kilowatt output is typically limited by the size of the inverter. So if we have this chart of needs, so my home might be using, I don't know, let's just assume like this baseline at the bottom is 1 kilowatt. So I might be running a kilowatt overnight. Then I wake up and I start turning appliances on. I start making some coffee or making myself breakfast. My loads, my kilowatt demand is going to increase up until a given time. You know, arbitrarily, looks like 1 p.m. and maybe this is 5 or 6 kilowatts. I've turned on my air conditioner and the startup is forcing my total demand to reach its peak at 6 kilowatts. However, it immediately declines, and let's say it is going to be more consistently around 4 or 5 kilowatts. I still need an inverter to achieve my maximum kilowatt demand in order to turn my load needs on. So I need to make sure that my battery also, my battery inverter combo can provide the maximum kilowatt demand that my loads are requiring. So in order to make this demand maybe a little smoother, if I have a large motor or a pump or something that has a significant inrush current, I will put a sort of soft starter on. So you can get devices that will tamp down the inrush current so that it smooths out your demand. And that helps because you don't need your inverter to be so large that it hits that peak. If the peak is reduced, then my inverter may be able to be smaller. So I'm basing my kilowatt inverter size based on my instantaneous demand, not based on my total kilowatt hours. I also like this chart because the kilowatt hours is the total need that I have over a given day, but the kilowatts is going to be just the instantaneous peaks and valleys over that amount of time. So what's our kilowatt load max? If I'm able to spread out the loads I'm using, so if I'm going to turn my electric kettle on, and then I'm going to wait and turn it off, and then I'm going to turn my toaster on, it's going to achieve the same kilowatt hours. I'm using the same amount of energy, but I'm keeping my kilowatt demand lower because I'm using one appliance and then I'm turning it off, and then I'm using the other appliance at a different time. And that's really important by not spiking. It's sort of like if you've ever blown a fuse in your house by, turning all the lights on, turning all your appliances on, maybe turning a hair dryer on. You're putting so much emphasis into your system at an instantaneous time that the breaker trips or you blow a fuse. Compared to using one appliance, turning it off, using the next appliance, turning it off. That really helps smooth the kilowatts and keep your demand lower, which is important when you're in a emergency setting, so that you know that your battery and inverter are not having to really be used a ton at a given time. I think that's it. Yeah. Thanks everybody for being here. Chelsea, if we don't have any questions, then we will end this recording and have this saved to YouTube for anybody if they want to watch it again.
Yes. Does anyone have any last minute questions before we leave? No? Okay, sounds good.
Thank you.
Oh, can we get a copy of the PowerPoint? Yes, I can.
Sure.
I'll email it to all of the registrants and the attendees, and then I'll email the video link as well.